We saw that the new 25km images from LRO are suspiciously not any sharper than the earlier 50km images. Neither the terrain or the alleged man-made equipment are resolved any better. Let's now examine the photographs in more detail, starting with the boot prints. As before, there are boot print trails linking between various stations in each site. Once again though, the trails look very dark when compared with their surrounds. As I discussed earlier, to get the tracks this dark, you'd need 6 rows of end-to-end prints side by side with no gaps in between. I won't go through that again, but instead point out something that should be easier to follow. If you were to walk along a beach on dry sand, but close to the water, the prints you leave behind will be dark because what you kick up contains moisture. But say you did that further up where the sand is dry underneath. In this case your prints would be far less distinct and the same colour in the surrounding sand. In fact, you'd only be able to see them because of the shadows they cast. And there again, they'd only stand out if the surrounding area was flat. But suppose that sand was already churned up before you walked over it. In this case it would be difficult to make out your prints, even at ground level. The moon is a similar situation. It's completely dry and the surface is very uneven, having been repeatedly battered by meteorite strikes. Therefore, one would have to wonder how it would be possible to make out any prints clearly from the ground level, let alone high up. Beside the LEM, this darkening effect is even more pronounced. On this Apollo 14 image, the multiple overlapping boot prints have turned the soil surrounding the LEM completely black. And before anyone wants to say it's just a shadow, note that it surrounds the LEM on all sides, and is far darker again than any of the surrounding crater's shadows. Arizona State University's LRO principal investigator, Mark Robinson, was also puzzled by how dark the prints were. He hypothesized that the LEM's exhaust plume had turned the landing area white, and that the astronauts then dug up darker material from underneath.
One of the things that's very interesting, and you can see this quite clearly in the Apollo 17 and the Apollo 12 images, is they're right around the lander. The surface is very dark, and I'm not talking about where there's shadows, but look around the shadows. And then on a big halo that's maybe about 100 to 200 yards wide, it's very much brighter. And then the tracks are superimposed on top of the bright halo. And we believe the bright halo was caused by the engine plume that was able to scour the very finest particles away from directly at the landing site. And that made the interior part darker, but it spread those bright, small grain-sized particles around in a circle, and that's why it's bright. Then the astronauts walked across it. And one of the interesting points about we're trying to figure out is, did the astronauts simply kick up darker material that covered up that bright material, or is there something else going on? And the reason there's a question, is there something else going on, is one of the interesting results after the Clementine mission was when the Clementine data were calibrated, scientists realized that the samples that were brought back from the moon were somewhat darker than the actual area on the surface where they were sampled. And so it's just the act of sampling the soil somehow disturbs a very, very fine texture and changes the brightness. And this is a big question that photometrists try to answer, is how does light interact with the surface of such a fine-grained regolith?
So to recap, as the lens came down, its exhaust separated the smaller sized brighter grains of regolith from the larger sized dark grains, and then deposited the lighter shades of these grains as a top layer over a 200 wide yard area. The astronauts then walked through this, resampling the darker grains to the top layer again. Right. Here, Robinson is calling on what is known as the halo theory, a claim that each of the landing sites shows a brightened patch of ground, and that this brightening, or halo as they like to call it, is due to the disturbance of dust by the engine exhaust during touchdown. I dealt with the halo theory in an earlier video, but in summary, each of the so-called halos have turned out to be nothing more than the sunlit sides of giant impact craters, or in this case, other tilted terrain. If we look at this earlier Lunar Orbiter 3 image of the same area, we see this halo is only partially there due to the sun coming in from the opposite direction. It has nothing to do with engine bloom disturbances, it's just tricks of the light, as these false colour renditions particularly reveal. Plus, if anyone wants to claim that the tracks are as dark as they are due to them being made on the halo, then how do they explain this Apollo 14 image with astronaut tracks extending all the way to Cone Crater? That's a distance of 900 meters, or 1,000 yards, 10 times what Robinson suggested. Okay, now we'll turn to Surveyor. You may recall when the first image of the Apollo 12 site came in, I noticed that the Surveyor 3 craft registered as 2 white spots, possibly the boxes on either side of the craft, and they were aligned east and west, rather than north and south as seen in the Hasselblad images. Then, when photographed at 50 kilometers, the Surveyor appeared as a dark smudge, despite the sun being directly overhead and the LEM appearing brightly lit up. Here again in the 20-kilometer image, the LEM appears brightly lit, and yet the Surveyor appears black. Although this time, it appears as a small black rod with a little bump on the bottom. I'd say that it looks like a letter T, if not for the fact that the bump is so short. I'm hard-pressed to find any comparison between this and the earlier shot. As was the case with the Apollo 14 images, there are inconsistencies despite similar lighting conditions. Flipping back and forth, I noticed the shadows cast by the craters and the lunar module are quite similar in length between the two. The only glaring difference is that the terrain in the 25-kilometer image looks much brighter. But after comparing the two, it appears the latter image has been intentionally brightened. After darkening the image, the lighting looks about the same in both. So to sum up, 2 different photos of the same location, taken with near identical lighting conditions, and yet the Surveyor only appears brightly in one of them. Give me a break. Turning now to the rover, if you recall back to my earlier video, when the Apollo 17 rover was photographed at 50 kilometers, it appeared completely black, despite the fact that the rover has many bright surfaces. If we look over here, the note below this arrow says LRV Final Parking Spot. LRV stands for Lunar Roving Vehicle. But can you see the rover? It's just a black smudge, almost like the shadow underneath, but without the rover on top. Here are some surface photos of the Apollo 17 rover. And here's an overhead view. As you can clearly see, the rover has many bright areas, much brighter than the moon's surface, so many parts should show up bright in the LRO images, just as parts of the LEM's descent stage show up brightly. Yet every part of this rectangular smudge is dark. What about this small rectangle to the right? Could that be it? Nope. It's only 2 pixels wide versus 4 pixels for the wheel tracks. This one I extracted from the raw image. Not as dark, but still no bright areas. Now I know some propagandists have a special ability that enables them not to see things everyone else can. Perhaps this ability also works in reverse. But to me, it looks like a patch of burnt ground. Or maybe the rover caught fire after they left. Yeah, that could be it. With this new image taken at 25 kilometers, it's an improvement, but only slightly. It's still noticeably darker than the surrounding area. Again, keep in mind that the lunar soil has the reflectivity of asphalt. So for the rover to appear even darker than this is puzzling to say the least. During the teleconference, it was repeatedly emphasized that the vehicle could easily be seen, and that you could make out one of its wheels slightly turned.
It's pretty neat because you can actually begin to, because you know what the LRV looks like, you can actually see, if you squint really hard, begin to resolve the seats and the fact that the wheels were left turned slightly to the left. So I invite you to go to that webpage and look at that.
If you can see that, I need to see your optometrist. Quite frankly, the Atari 2600 had more convincing graphics than this. Even if I was to use my imagination and try to make out something that resembles a car, I'm having trouble seeing how it would compare to the Rover. There is a top view of the Rover, printed on page 204 of the book, Virtual M, and although the wheels seem to sprout out from the car, they are quite reasonably close to the chassis. Here, the only thing that I can assume is supposed to be the wheels seem to jut out from the corners, and even that's using the imagination. In their full caption for the image, NASA supplied this image with lines pointing to what are supposed to be parts of the rover. Even with the pointers, and squinting really hard, as Robinson suggested, I still can't see it. And it's really funny how the pixels they claim are the fenders and the chassis just seem to blend in with the terrain, despite registering so clearly in the Hasselblad images. And if these are supposed to be the front wheels, where's the back one to the right? Did it fall off, or is it also blending in with the background? But there's one anomaly that's more puzzling than the rover itself. That would have to be its tracks. Stay tuned for the next video in this series, in which I will address something quite interesting that I didn't cover in previous videos.